Alright, in this problem we are asked to find the limit as x approaches 1 of the square root of 5x plus 4 minus 3 all divided by x minus 1. Now it looks like a real bugger of a problem, that square root and irrational function going on. And before we actually approach it, I want to look over to the right here and look at kind of some steps and some guidelines for when we are evaluating limits analytically. That is, when we're trying to evaluate a limit without a numerical table or without actually graphing it and looking at the graph. The first thing you want to do is try direct substitution. So I want to go over to my problem and plug a 1 in for every x just to see if the limit works. But as I see, if I plug in a 1, I get 1 minus 1 equals 0 in the denominator. So that's a problem. So I do see that direct substitution does not work in this, and we're going to have to try something else out. But always do a quick glance to see if direct substitution works. Especially as you get further into limits and they get more difficult, you always assume direct substitution doesn't work. But it might, and you might save yourself a lot of work by just starting right there. Alright, so direct substitution doesn't work. So now we've got to work and try out some other algebraic method. And these are all, we're just going to have to look at the problem and see which kind of best fits it. You can factor and cancel, and that works really well if it's a rational function with a polynomial on the top and polynomial on the bottom. So you'd factor each and then cancel out common factors, and hopefully that takes away the problem. We can multiply it by a conjugate, and that works well if on the top or the bottom, primarily the top, you see essentially you have two terms, like a term there and a term here, separated by subtraction or addition. And this one pops up a lot when you see, just like we have here, of a square root and then just a lone number on the side. So in fact, we are going to use multiplying by a conjugate in order to solve this problem. But let's look at the other options. You could use a trigonometric identity. That could be switching tangent to its sine over cosine. That could be taking sine squared plus cosine squared and having it equal 1. So of course, if you're dealing with trig functions, that could be it. You could multiply by 1. That's actually kind of what we're doing with our conjugate, as you will see in a second. But multiplying by 1, and what I mean by that, it could be multiplying by like 3x over 3x. So that's 1. Or it could be multiplying your problem by square root of x over square root of x. Something like that, some form of 1, quote unquote. And there are other algebraic methods, those are sort of the common ones, but there are other methods that are very specific. So sometimes you just got to have a little fun with it and play around with your problem. And then you have the squeeze theorem, which that's sort of a blend of graphical and analytical method. But that's where you would have to come up with two new functions such that one function, g of x, is always less than the function you're looking at, your f of x, which is in turn always less than h of x, except for the limit point where they kind of squeeze together, and graphically this would be your f of x function, and they'd squeeze together there, and that would give you your limit point. But we're not going into the squeeze theorem here. But that would be another method if your algebraics fail. Alright, so I'll bring this off to the side, and let's look at the problem. As I said, we are going to multiply this guy by a conjugate. So I'm going to look at my problem, and the conjugate, you look at the conjugate of the top. So that is where you use all the same numbers, but you switch the sign between your terms. So I'm going to multiply by square root of 5x plus 4 plus 3. Notice how I changed that plus. But I can just multiply by something. That would change the value of my function, of my limit. So I have to multiply by the top and the bottom, because here I'm multiplying by 1, so nothing really changes. Alright, so this we can now distribute on the top and on the bottom. Now up top, we have So the long way is to double distribute. So square root of 5x plus 4 times square root of 5x plus 4. That would be 5x plus 4. And then we have plus 3 times the square root of 5x plus 4 minus 3 times the square root of 5x plus 4. And then lastly, 3 times 3, so minus 9. And I'm going to come back to the top in a second. The bottom, let's leave this apart. So let's not distribute. And this, maybe in the end we will distribute, maybe we won't. But a lot of times it's helpful to leave your denominator undistributed in these conjugate problems because something might cancel out nicely. Okay, look at up top. So we clearly see that these cancel out and we are left with the limit as x approaches 1 of 5x plus 4 minus 9 all over x minus 1 square root of 5x plus 4 plus 3. Now up top, what would have been easier is to kind of notice we have a factoring pattern in reverse. Up here, where I multiplied by the conjugate, I had a minus b times a plus b, where my a was the square root of 5x plus 4 and my b was 3. This, if I double distribute, is always a squared minus b squared. Or, as we should have recognized, it is our difference of squares in reverse. So if we could just save ourselves a lot of time and recognize, so I have my a and my b, a and my b. So those distributed together are just a squared, so down here it drops out of the square root, and then b squared, which is 9. And then of course it's a squared minus b squared. So that would have saved us a little time, and that's something you should be good at because you want to go quick because we got other things on our mind when we're doing calculus and simple distribution. Okay, we can see that I can simplify the top of my limit, so let's just do that real quick. 4 minus 9 is negative 5. Ooh, and I see something nice here. Because as of now, nothing has been solved in my limit. Still, if I plug in 1 into my limit, I still get a 0 in the denominator. So nothing's saved yet. But I see something nice up top. I see that I can factor out a 5, and I'm left with 5 times x minus 1 on the top. And then on the bottom, I have x minus 1 times our square root. And this allows me to notice that I can cancel out the x minus 1. And that's kind of why we left it undistributed. Because the fact that it is undistributed, we can clearly see that the x minus 1s cancel out. And that's the beauty of our conjugate. Our conjugate gave us this factor up top that we could cancel out. And that canceling happens a lot at that end stage of a conjugate. So when you are doing this problem where you are multiplying by a conjugate, I would leave the denominator unfactored. Or at least one side unfactored, because that clearly lets you see you can cancel out the factor. If we had distributed in, we might have had a hard time seeing that. We might have had a problem noticing that I do have an x minus 1 on the top and the bottom. Alright, so I canceled out that, and that was my problem. That factor was the problem when I plugged in 1. So let's try direct substitution again. I'll switch to green since we're on the home stretch here, and it's going to be all hunky-dory. So I'm plugging in 1 for x, so 5 times 1, 5, plus 4, and then outside of the square root plus 3. And that is equal to 5. Square root of 9 is 3, plus 3, so that equals 5 sixths. And we see that direct substitution at that later stage did indeed work. And voila, the limit as x approaches 1 of our function is 5 sixths. So I'll zoom out and let you take a look at the original function again. Multiply by a conjugate. A lot of times when you see a square root and then plus or minus another number, and it's a rational function, you will solve that limit using a conjugate pair.